Yes, sir.
So
Okay.
that gives you where your file and your folder or basically your project is stored. Okay. Reason being that when you write, you must be able to know where it's stored. I can ask you to send me the file so you won't be asking where did I save the file. Okay, so it's in this directory. So if I go to that directory, I will see it. Let me just click on this Explorer. So I go to my documents, I go to code blocks, you will see first probe. You can see first probe, and you can see the main file. That's the main file there. You can preview it, you can see it. All right, so that's so that if I ask you to send me the file, you will send me the entire folder, not a sub file, the entire folder, this entire folder. That's what you send to me. Okay, I think that is clear enough. Let's go back. Um, so this is what you do when you have this file. The beautiful thing I love about code blocks is it helps newbies or anyone help you add a pre-defined header, some headers for you, or some basic template that you can start with. You don't need to worry about typing, oh, my main function. You don't need to worry about certain headers. It helps you add those things. All these things will be explained to you as you go on. Okay, so there's something you need to see that this environment is my text editor where I can do a whole lot of things. Okay, and if I'm done with my code, typing my code, I can run my code. So here you will see build, here is run, here is build and run. So most of the time, I just build my code and run it. So clicking on this, it will run this code, this predefined code to display to you hello world. Okay, so someone is here, Toluwani Alao. I can say hello Toluwani. So all these things you will understand them. Don't never mind. I'm just Toluwani Alao. Hello Toluwani Alao. Okay. Welcome to the programming class. Programming class. Okay. So, so never mind. I'm just trying to show you that this environment is where you type your program. All right. So I can run my code. You will see hello Toluwani Alao. Welcome to C programming class. Um, I hope you can still see my screen. Right. You're welcome. You're welcome. Is my screen visible?
Yes, sir. It's visible to us.
All right. Thank you so much. So basically this is the environment where you type. You can see I did not exit my environment before I run my code. Okay, so you write your program in this text editor, and when you're done, you can run to see if the instructions you've written has no error, has no syntax error. Then the compiler will help you compile your code to become executable, which your computer can actually now run. All right. So let me show you one more thing. Let's see if I yeah coming. Okay. So if you look at this lower pin I'm trying to stress it for people that love working in Linux environment. Okay, you will see that the bug in build here in this lower pane here, the bug in this folder, the compiler is GNU GCC compiler. You will see Ming W32-GCC executable. This executable This is the program or the compiler. This is the compiler that helps you execute your code. Okay. GCC, these are switches. All it's saying is compile this code, this main.c, compile it for me to give me main.o, output it. So you can see sometimes rather than you stressing yourself, just come here and you run your code. I'm just trying to show you that what you're doing here is what you could actually do in your Linux environment. Right. So let's start. Let's start. So you have your basic header files. We call these header files. Let me quickly explain this. These are files that contains some functions for you. Okay. These functions are necessary for you to be able to carry out certain tasks. You don't want to reinvent the wheel. Let's say someone has written a function to print to print to print your variable, the content of your variable, or you want to find the square of a number, or you want to find the square root of a number. Okay, rather than you add coding it, you have some header files which you can include. You can include means more like import these files into this environment. Okay, import them and I can be able to use certain features. Are we on the same page? Let me give you an example. Let's say I want to find the square of 4 or the square root of 4 whatsoever. So let me come here. Let's say um I want to find, let's say, the power. This function will help me find maybe this power of any number. So I can say 5 uh, raised to power of of 3. Okay, so let me save it in one variable. Let me say results. Please never mind what I'm trying to tell you, what I'm showing you. This power, you might not understand how it works, or it will not work until you include what we call or like maths. There's a maths header, maths. You can see math.h. So in the math.h, okay, let me just delete this. In math.h, there's a function called pow. You can see there's a function called pow. This function says this pow takes in a double, a number, followed by a number. It accepts 2 arguments. Okay, so let me just say pow. Let me say 5, 3. It means I want to find a 5 raised to power 3. 5 raised to power 3. So rather than me writing a function to say 5 times 5 times 5, or trying to say if I have 100 raised to power, writing them, a function just exists which I can use. Okay, so I'm coming, so I can come in and say maybe I want to print out my results. The value of the answer is, okay, so never mind, never mind. I'm just trying to, all these things you will understand as go. If there are errors, it will tell me. Okay, so you look at it, it says 5 raised to power 3 is 5 times 5 times 5, which is 125. The answer is 125. This, you can see I did not explicitly write 5 times 5 times 5. What if it's 100 times raised to power 10? How do I do that? Okay, so I could actually write 100 times 100 times in 10 places, but there are functions already available for me to use. available for me to use. If those functions does not exist, I won't be able to use them. So it is possible because I was able to include certain math library. Um, okay, it still works. Certain libraries like stdio math.lib, if I comment this out, it might not work depending. Okay, so let me say I view them, I run. Okay, it still works. But certain features are not possible. All this is already embedded, are not possible because if I need them, they're already included by default, they're already included in this math library. Okay, so the first thing I want to show you before we dev properly is comment, how to comment. Okay, comment, how to comment. Sometimes when you write program, you want to comment, you want to write the meaning. Okay, so you for you to have comment, you have what we call a single line comment. A single line comment um is just two forward slash. Okay, when you have comment, the compiler ignores your comment. Comment is just for you to have a description of what you're doing at a particular time. So I can say I included this so as to use math functions. Yes, math functions. You can see. You can see they are ignored. If you run it, they are ignored by the compiler. You can see they are ignored. Okay, comment is just to give you description. Sometimes as programmers, someone will pick up your code and need to understand what you've written. Okay, so comments are important. So two forward slash for just a single line comment. Sometimes if you have any file or any header like this and you want to ignore them, maybe you are testing out a code. You are not too sure. You want to test out a code. Okay, rather than deleting that section of code, you can just comment the code out. You've not deleted it, but you just ignored it. You want the compiler to ignore it. Okay, so that is a single line comment. Another one is you can have a multiple line comment. Multiple line comment starts with forward slash asterisk and followed by asterisk forward slash. So with this multiple line comment, is always used to give a description of what you're trying to do. Okay, I can put my multiple line comment at the beginning of this program. Let's say something like this. My my multiple line comment. It means my comment want to spam multiple lines. So I can come here that this program is written by Adeni. Okay, it solves the quadratic, let's just say something, quadratic equation. So this could be, okay, I can say written, written, um, written in 2026, something like this. Okay, so you can see it spans multiple line. Can you guys just give me a minute? Let me respond to this call.
So
Sorry, sorry. Hello, always mute yourself. So so that's just multiple line comment. You can see it spans multiple line. I don't have to be doing forward slash every time, more like to comment everything. So this is multiple line comment and it is always written in this way. Okay, so that's comment. I've been able to explain single line and multiple line comment for you. Okay, so you always see this in real software, in real production software. All right, so let's go on. Let me just so like I said, these are headers which are included to really help us with certain functionalities. Always mute your mic whenever you join the class. Okay, so if I needed some mathematical functions, right, so so if I need any mathematical function, right, like power, like square root, like log and all that, they are all included in this math library. Okay, so I was expecting it to flag it for me when I commented it out, because it is added. Okay, so that's just it. Okay, so this std io is always good for anything input output. It means standard input output library. This is standard input output library. You understand? Standard input IO means input and output. So it's the one responsible for your printf, your scanf, and all that. This standard library contains most used libraries, most used functions. Okay, so your functions. So if you are dealing with math functions, you want to find exponential, logarithm, and all that. All these functions, different functions, are placed under the math library. Okay, anything input and output is placed in standard IO library. Okay, header and all that. So that's how all this thing works. Um, so your main execution, the program starts running from the main function. This is what we call the main function. This is a function, the main function. Okay, so execution starts from the main function. All these things inside the main function are executed. Okay, so we can delete them by default. We can delete them. If we run this, it will show nothing. Okay, it shows nothing. All right, so I want to start today's class with the understanding of variables. With understanding of variables are location reserved in your computer memory where you can save a value. Okay, variables are what? Location in your computer memory where you can save a value. Now, and for you to be able to reserve any space in your computer memory, you need to pre-inform the compiler what type of variable you want to what reserve. Okay, what I will be reserving, what will it be storing? Will it be storing whole number? Will it be storing real numbers? Will it be storing alphabet? Will it be storing strings? Or will it be storing Boolean values? Okay, let's give an example. Like I said, variables are what? Are location, in your computer memory where you store your value. So, how do you say variables? How do you define your variable or you declare your variable? First, you need to type the data type. So, if I want to store my age now, okay, I know my age always have an integer value. Okay, the number for my age is always whole number, right? So I will have to type integer int. So I can give a variable name, okay, and say, oh, the variable which I'm creating is age, right? But I cannot just type age alone. I have to tell the compiler that yes, my age takes integer value. And it also makes sense. Our age is always whole number. You don't see someone saying, I am 10.5 or I am 20 and they have years. There's nothing called 20 and they have. Yeah, either 20 or 21. So 20, 21, 100, 500, 1,000,000, they are all integer numbers, whole numbers. Okay. So if you have to create a storage in your computer memory, okay, called age, the storage called age, you have to first of all define the data type. What type of data do you want to store there? Okay, so this is just variable declaration. I've just declared this variable called age. Now, this age will be reserved for me in the computer memory. Now, in C programming and in C++, every sentence you make, you always end it with a semicolon. If you make a sentence, it is ended with a what? With a semicolon. So with this, I've reserved a space in the computer memory called what? Called age. However, this computer memory I've reserved has no value. There's nothing in it. There's no content in it. So there's no value in it. So I can come here and say age is equal to 20 now. I'm done. So every statement, you end it with a semicolon. It means I have now put 20 inside what? Inside my value, my variable. Age is called a variable. All right. So that's how to declare a variable. So we have different data types. Now, my data type inform the compiler what type of value I want to store in my variable. What type of value do I have to store in my variable? Okay. So like I've predefined now, this is an integer. Okay. Age should store an integer value. Integer means what? Whole number. Now, if I want to store real numbers, 10.5, like your CGPA, 3.47, 4.98. Do you understand? That is what we call real numbers. Okay. And if I have to declare it, I have to declare with a floating point. So I will say float. I can say float CGPA. With this, I have created a variable called CGPA or a location in memory called CGPA, and this CGPA can store floating point value because I've defined the data type to be float. Okay, it stores floating point value. So this, I just created this variable. It has no value yet. So what can I do? I can now say CGPA is equal to maybe 4.98. And every statement ends with what? A semicolon. Okay, so that is how. So when I initialize, when I initialize, it means I now put 4.98 into CGPA. Now, the way it works is it works from my right-hand side to my left-hand side. From my right-hand side to my left, that's how it interprets. So left-hand side, it copies the value into the from my right-hand side into my left-hand side. So it means CGPA in your computer memory, it now has 9.8. So anywhere you see CGPA, what you're actually saying is 4.95. Okay, 4.95. Apologies for the mix-up. So let me clear. Okay, so I can print out what is in my location by using the printf statement. With the printf statement, the printf function is a function that will always help you to output to the screen. Print function is a print function. It displays whatever is in your bracket in the parentheses like this. In these parentheses, whatever is in the parentheses, it will display to the screen. It will output it. Remember, standard input and output. So if you have to display anything to the screen, you have to output it. So let me go again. In your print function, if I want to print anything, let's say string, I will just put the string and say, oh, I love C programming. Maybe this is what you want to display to the screen. Okay. So when you click run, you will see I love C programming. Why? Because this code will help you print to the screen. But now I just quickly want to print to the screen the content of my variable. So I can just say um, maybe your CGPA is first you specify, you put whatever you want to print in quotes. Then if I want to print a floating point value, there's something called format specifier. I have to tell it should treat it this way, the variable this way. Let's say f comma CGPA and what I want to print. Okay, so what I'm doing now is this. It will first of all print this string, and it will put this CGPA value in this particular location. So it will display your CGPA is 4.98. So anytime you want to display to the screen, you have to put your format specifier. If I want to display CGPA, if CGPA is an integer, I have to say this format specifier to be D or sometimes U. Okay. If it is a floating point, I have to put F, okay, to the screen. So it will substitute, put whatever it's on your right, it puts it here. So then you have a whole text, your CGPA is this. Let's see how it works. So you can see your CGPA is 4.98. It will help you finish off with zeros. So 4.9800. Okay. So with this, I was able to display the content of the CGPA. Okay. So one thing about variables, from the word variables, it means whatever you put in can change. Variables means things that can change. Okay. So if my CGPA is 4.98 and now my CGPA, maybe later in my code, my CGPA is 5.00. Okay. If I now run this code, what do you think will print for me? Anyone? What do you think will be printed? You can unmute yourself. You can put it in the chat box.
5.0.
5.0. Thank you so much. So, because you initially in this CGPA, you said it should be 4 point something. Now, you remember computer runs the instruction sequentially. This, then it comes after executing that, it comes here. So initially it was 4.98. Afterwards, it cleans it up and say no, the updated CGPA is now 5.0. So when you print it, you will have 5.0. Okay, so you need to know. Okay, you can see your CGPA is 5.0. If I want to print the previous one, it means I have to put my print here and run. You will see your CGPA is 4 points. That's for the previous. Your CGPA is 5 points. So I can come here and say is now the CGPA is now, so the previous are now the correct. All right. So I've explained two data type now. One data type is integer for whole number. The second data type is float for real numbers. Okay. Now I want to see if, let's say for example, I declared my data type to be an integer. And when you say your variable to be an integer, it means it only stores whole number. Now, for example, now, if I come to this next line, in line 9, to assign 4.98 to this location, to this variable, what do you think it would do if I come here and I want to print out my CGPA? Let's see what I will have. Look at it. Your CGPA is now 4. Your CGPA is now 5. Is that right? Does my computer execute, give me what I want? Give me a minute. So, is this okay? Does the program run? Yes, it ran, but does it give me my expected output? No. What do you think? Is this a problem or not? Let me hear from you guys.
It is.
It is. Oh, okay. Why is it a problem?
Well, because um, it's not giving us the specific data that we give to the computer.
Yeah, yeah. Again, imagine your CGPA, real CGPA now is 4.98. And by mistake, when we computed it and we say your CGPA is 4, you just go home and have a nice sleep and say, oh, they said it's 4. What do you do? I'm very, very, very sure that the next day, even you will not have enough good night rest. You'll be boiling like, let me come and show them in the next. Do you understand? So you need to be able to use the right format specifier. One, also you should be able to use the right data type. The right data type. You ask yourself, what I want to store, will it be whole number? Will it be um, real numbers, floating points, numbers with decimal points? Okay. Will it be variables, alphabets, right? Will it be Boolean values? If you can be sure about that, then that will inform which data type you should use. So I've been able to talk about integer. I've also been able to talk about floating. Another thing I want to quickly show you is this line 8, I was able to declare the variable. Now I was able to initialize or assign a value to that variable. When you assign a value to a variable, we call it initialize. You assign a value. Now, I could, in the same way, create a variable and also initialize it. I can, in a line, create a variable and also, it's just like you create a bank account and fund it immediately. Sometimes you can create a bank account and not fund it immediately. Okay? So that's one thing I want to show you with the code run. Okay, something is still running behind the scene. Okay, will it work? Yeah, it will work definitely. Okay, so that's one. Number two, another thing I just want to quickly show you before I forget is if you have a floating um data point, you could also write in scientific notation. You could write in scientific notation, like you can say 2 times 10 raised to the power 5. So you can just say 2 exponential 5. That's um that's 20,000. Okay. So let's see floating f, the data f. So um let me rename the variable name. Let's say bank account, bank, bank um account. Okay. So everywhere you can say bank, you auto complete it, bank, auto complete it. So your balance, you can just your balance is your balance is. So you can come here and say exponential minus 5. Okay, something like this. Okay, so let's run and see. CGPO. Now you can see an error I'm having. I said CGPA equals this. Okay. Um, the, no, you should never use a variable you've not created or you've not defined. Okay. So I've not defined this variable called CGPA. Okay. So it's either I correct it to create that CGPA or I correct it to say bank account, because I wanted to just update it so that you see. So let's see. You can see your balance is, oh, there's a mistake. Is now 20,000 or 200,000. Yeah, 200,000. Now it is what? 0.0005. You can see. So you can use, for floating point, you can use this syntax. Oh, sorry. Let me quickly pick up the score.
Hi, sir. Hello, sir. Can't hear you, sir.
I took permission before I picked the call. I had to attend to something important. They needed my input. Okay,
Uh,
so um, I've been able to show you that you could also use scientific notation to be able to store your values. Let's also see, does it work for integers also? Um, let's see, D is the, yeah, it works. Okay, it works. So you can see that because I declare this as an integer, it truncates all the decimal points for me. And that is bad. Okay, you don't want to do that. So that's why you must use the right data type for your variables. I hope that is clear. Okay, so integer, float. Another one you could also use is double. Double is just more like float. It helps you take real numbers, but with more decimal points. Double. Okay. It also take the real numbers, just like this, just like your float, but it just, you will see you will not have any, you can see. But in real computation, if you needed more decimal points, more precision, you can use double. But double and float virtually does the same thing. Another thing you can, data type we have is your character, char. Char, let's say option, I can say option. Your char or character helps you to accept one of the variable, okay, one of the alphabet, A to Z, space bar, or space, okay, alphanumeric character. Your character will do that, okay. Anything on the ASCII table, I want you to read about the ASCII table. ASCII, American Standard Code for Information Interchange, okay. That is to say ASCII, okay, American Standard Code for Information Interchange, talks about all the characters um, being encoded in this format. You'll be able to see space bar, you'll be able to see other characters. Okay, so character helps you to take any of the alphanumeric keys. So I can say option equals. Now, if you are taking one character, A, B, anything, you put it in just single quotes. Okay, so I can say your option is, so character has a formal specifier of C. That's true. So option. Okay, you can even see it tells me option is of the data type character because that's what I declared it as. So let's see. Your option is A. Okay. Um, let's say space. If it is space, what will be my option? Space is also a character. You can see the space. Okay. Um, what about question mark? Question mark is also a character. Okay. Another another thing I want to show you is for every variable, for every ASCII character, A, B, C, D, small letter, okay, there's always a number attributed to it. Let me ASCII table. Let me just show ASCII table. Okay, there's something called ASCII table. It tells you the mapping of those characters. Um, so it's 7 bits. Look at it. Um, null. You can see null. The decimal zero represents or start of. These are control bits. Maybe start of line, end of terminal, acknowledgement, bell, 7. So bell is represented as 7. I can come here and put something like 7 there. And remember, 7 represent that bell. Okay, that's the numeric equivalent of that. So the compiler will treat this number as the ASCII equivalent. So if I run it, it there's a sound. I don't know if you guys can hear it because a bell is more like a sound. I heard the sound. You can try it again. Um, let's see. Um, no character. Okay, thank you. There's there's a description of every ASCII character. This no start of a text, end of a text. So end of a text, the number 3. So let's see. I can put 3 there. Okay, let me run it. You can see at. That is the syntax. I can even do this. I just want to show you some programming. I'm coming. I can just say int I equals 0. Uh, um, okay, so let me just do this. Um, for I equals 0. This is not necessary. For I equals 0, so I less than, let's say 255. Okay, or 128. Let me just do 128 or 127 plus I to do something. Um, okay, I want to print I. I want to print I. So new line. Good, good. If you see my screen printed all the ASCII characters. So let me do um side by side comparison. Mm, Side by side comparison. The first one, your option is null, nothing. Null, this is null. Start of header or whatsoever. If I zoom to the side, if you look at the description here, let me try to enlarge it. Hopefully, I will see the description. You can see the description. Okay, so null, start of header, start of text, start of header, start of text, at, end of bell, acknowledgement, bell, song. You can see all these. Okay, so all these are the symbol being represented on it. Um, so A, let's go to A. What is A? You can see at. At symbol is 64. So if I go down here, we will see the at symbol. At symbol is before A. I think it's before A. You can see at symbol is before A. Um, you can see at symbol before A. Before at symbol, you have question mark. You can say question mark, greater than, equal to, less than, semicolon. So I hope you understand what I'm trying to say. So there's a numeric. If you create a numeric variable, a character, a variable as a character, you can also assign a number to it, and it would give you the ASCII character, the equivalent ASCII character that you want. Okay, so I stop at 128. So okay, there. So that's just what I want to show you. Okay, that's what I wanted to show you. All these things are not far-fetched. Let me just You will get to this and you will even do better than me. Don't worry. All these are just some gymnastics. So I've been able to talk about character, char, data type only allow you to store just one alphabet. You understand? Or alphanumeric, anything like question mark, dollar sign, space bar, all those alphanumeric, like I displayed. Okay, your character would do that. Another one which you can also do that we also do is Boolean. But however, um, Boolean, you won't be able to use Boolean except you add an header. I'm not too sure. I remember the header. I can quickly go online and see if I can. Just trying to see if I can um see anything on Boolean. I can go online and see. These are headers that will help you do some wonderful things. Okay, some important things. So if I say bool answer, let's say is to equal to, let's say, true. Okay. Um, let me save this here. It will give me an error. It will ask me to add an header. You can see it's giving me it's pointing. Okay, let's see. It will still give me an error saying that data type. So there's an header I must include. Okay, to be able to do that. So I
Sir,
can come here. Yes,
I checked the other already. It's SCD.
maybe bool std sums. So, but I just want to show how guys can figure things out. So I don't remember all things. stdbool.h. So you can see where header comes in now. It means if I have to use this Boolean data type or this value true, I have to include this header. Okay, include std bool. Yeah, that's good. So if I will run it, you can see it runs telling you, oh, true means one, false means zero. Sometimes when you want to check a condition, whether it's true or false, okay, then it will return either true, or false for you. So, true, false, false means zero. Okay, you can see. So these are the fundamental, we call them fundamental data type. As you go on in programming, you will create your advanced, your own user defined data type for you. Okay, so that's on and on another beautiful thing about you using IDs. Let's say I make a mistake and just type, instead of me to type false, which is recognized by the compiler, I make a mistake and I run it, it will not run. However, it would give you the area where you are making the mistake. So in this your build message, you will see it says the error you are having is in the main function. Oh, so this is the main function. So in this area, it's saying the error is that these files you said is undeclared. Undeclared in the sense that what it does not recognize, it always wants to assume that you did not declare it. Okay. And by the time you click on it, it will take you to the environment where you are having this. Oh, so as a programmer, you see that, oh, I forgot to put the E. Oh, that's it. There's no way you will write program without making mistake. But your ability to remove the bugs, to remove the error makes you a great programmer. To date, to tomorrow, I will always make mistakes. I will make certain mistakes because you will always make mistake, correct the mistake, perfect your code, before you have a full-fledged working program. So now I've corrected it and I am good. So I've been able to talk about variables. Variables are location and memory space reserved for you. Okay, the memory space where you can put a value. So I can say, apologies, I can say int a, int x, comma, int x, comma, y, comma, z. With these, I've been able to create three variables, x, y, z. All of them are integer. Anytime you want to create variables and they are of the same data type, you don't need to come and say, oh, int x, int y, no, int z. You don't need to do that. You can all create them on the same line by just saying int x, y, and z. If you try to run this code, it will give you an error because you cannot redefine a variable. You've already defined a variable and you are trying to redefine it. It will give you an error. Okay, so if you point your mouse, you will see it says Z is of the type int. Z belongs to main and is of the type int. So you can see that these ints affect. But if, let's say, for example, as long as you've not put your semicolon, more like you are done, you can still continue to create your list. Is that okay? But the issue about variable, there's a whole lot concept on variable, is a variable, the variable name which you will give to that location, the name you will give to that location is called variable name. Okay? That name must follow certain syntax. Okay? They'll always tell you your name, your variable name must not start with a number. So I cannot say my variable should start with OX. No, it should not start with a number. It must start with a alphabet. It can also start with a number at maybe X1, X2, X5. Well, it's permitted, but it should not start with a number. It could start with an underscore. Let's say underscore X, no problem. Underscore X1, no problem. But it should not start with a number. Okay? They also tell you that any variable name you want to give must also have some meaning. If I say X, it does not carry much meaning. But let's say I say age, okay, or student age. With this, it carries more meaning. Okay, it carries more meaning. Okay, so these are one of those things they tell you about variable. Your variable name should not be extremely long. You cannot say, oh, student age of University of Lagos, and no, it's too long. Okay, it's too long. Just make it more just descriptive. Student age, student CGPA, okay, CGPA. And sometimes in some programming instance, some people use what we call Hungarian notation. Hungarian notation. So in those Hungarian notation, whenever they are creating a variable, they always try to put the data type behind it. The data type behind it. So they could say, if it is age, let's say the variable is age, they will put IH there. So when they see this variable, they know that, oh, it's an integer. So that if later in their code, they don't assign a floating point value or a character or a boolean, they know it's an integer. So this is just an Hungarian syntax. It's not compulsory you do it. Some does what we call camel case. So they can just say student, they now start with age. That age in capital. Okay? So that's camel. Camel case in the sense that a camel always have a hunchback. So it is flat here, it just rises here. So okay, they call it camel case. Okay. Um so that's basically all to variable. Variable. Now, why do we always have variables? Variables are used when you want to uh, keep track or you want to save certain value. Okay, I could um, actually not say have a variable and maybe I want to add 3 plus 5. I could actually just call the print function and just do this. 3 plus 5 is an integer, right? So I just say integer and just say 3 plus 5, something like that. Okay. Oh, sorry. Let me comment this out. The error is because this variable answer is not defined. So you can say 3 plus 5 is 8. But if, let's say, I want to save this result, I want to save the result of 3 plus 5, what I would do is I'll just create a variable called result, okay? And I'll say result equals 3 plus 5. So, and then reuse it later in my code. Maybe I want to print out the result, okay? That's 8. I can later reuse that variable and say result equals result times 5. Okay, I can say result equals result times 5. It means the former value of result times 5 should now be assigned to where result, to the new value. So the new variable called result should be equal to the former value called result times 5. So remember, our result is 8. 3 plus 5 is 8. 8 times 5, that's 40. So the new value of result should be what? 40. So if I copy this and print this, let me put this so that you'll be able to see the changes. So you can see 8 and 40. Okay, so those are the essence of way saving in a variable. So every time you're writing, you always want to say, oh, whatever input I have should be saved somewhere. Okay, so that is variable for you. Okay, so let me quickly do a recap. Quickly do a recap. So the recap is I've been able to talk about variable. Variable is a location in memory where you can save a value. A location in memory where you can save a value. Okay, and that location in memory, we can give it a name, and that name we can give it is a variable name. So result is a name in memory, a name of a location in memory. Result, okay, is a name of what? A location in memory where I now did 3 plus 5, 8. So with the next line, I was able to print out the content of result, which is 8. So it prints 8 for me. This slash n means new line. So after printing 8 for me, can you see it prints 8 for me? Then new line means come to a new line, more like an enter key. It's just like this. If you look at your keyboard, you will always have an enter key on your keyboard. If you look at it critically, the enter key on your keyboard always have this symbol. It means if you've written any statement, maybe you are typing and you press enter, it means come down and go to the beginning. Do you understand? So come to a new line. So every line, there is a line where you can type. So when you type slash n means come to a new line. Okay, so that location in memory, I can undo and just do this. Okay. Um, the result now, I now say the value of the old result times 5. So 8 times 5, this is more like. So there's a symbolic representation. So this is 8. 8 times 5, that's 40. Now replace it where? Put it back to result. So it means I clean this, then update it with what? Result. So the next line of command of code says now print it out. So when I printed it out, we could see what sorry, what has been done. You can see 40. All right. Now there's something I need to quickly tell you or quickly show you. It just popped in my mind. Okay. Now this concept of variable means the value in that location, memory location, can change. Okay, the value in that memory location can change. Now, sometimes we don't want the value to change. We want the value to remain as it is. I don't want you to alter the value. Then we can make it a constant. We can make it a constant. Okay. You know, in science, in scientific world, we always have constant. Constant like Planck constant, Avogadro's number, molar mass of this, number of moles in this and all that. Okay. So to make a variable a constant where we cannot change it, what you do is before the data type, you type the word const. You can see any word you see that are in this blue, it means they are reserved words. They are recognized, they are special words. They are more like a command. They are keywords. We call them keywords. So it gives instructions. So I can say pi equals 3.142, So this is a float. So I come here and change it to float. Okay. So now look at it. This is a constant. I cannot change this value of pi. If I come here and say pi equals 5 point or any number, I change it. If I try to print it out, the float pi equals. If I try to print it out, I will have an error. So look at the error. What is it saying? You can see it points to me here. And coming down here, what is it saying? Error. Assignment of read-only variable. What does read-only variable means? What does read-only? You can only read it. You cannot write to it. You cannot modify it. So in computing, we have two operations you can do. You understand? Or three. You can read from a location. You can write to a location. Read means fetch what is inside. Let me see the content of what is inside. Write means modify it. You understand? Modify it. And read write means you can read from it. You can also modify it. So this is telling me that it is read only variable. You can only see it. You cannot modify it. You cannot write to it. You cannot change it. It is not variable. It cannot. You cannot decide later on that I want to change it. So to make things a variable, okay, you have to change it by putting, or to make it a constant, okay, by putting const. So I can't change float, pi, but I can see the content. It is read only. You can see it is read only. I can see the content. Okay. Now another thing we do is there's something called macro definition. Macro is what we call a symbolic representation. So just like this, hash, you can say hash define pi as 3.142. Okay, this is macro. macro definition. So what it means is anywhere you see pi, I am defining pi to be 3.142. It means anywhere you see pi, just substitute it as 3.142. Okay, so I can come here and print also. So it works. Can you see? I can work with it and just say um just say float radius equals pi times times um times 5. Let's just say times 5. So I can come here and say radius radius. Okay. So what this would do is 3.4 everywhere you see 5, you put is put 3.142 times 5. So this is just 5 pi, abi? So if you run it, you can see the result. Okay, so that it's as simple as that. Very, very simple. As simple as that. Okay. Um, Programming is wonderful. Every line of code you write it, and if you make any mistake, the compiler will tell you correct yourself. Okay, so that's the work of programmers. Um, so that's variable declaration, um, variable initialization. I've also talked about different type of data types. We have integer data type, which we use as int, floating point data type to help you take care of anything with decimal points. Also told you about double. Sometimes you can see double. Double also works on real numbers, anything with decimal points, but it could actually take more precision, more like it can store more numbers. That's it. Okay. Um, you also have char character. Okay. we and character takes what alphanumeric keys, anything alphanumeric, alphabet, special characters. It does that. And also, I was able to talk about boolean, boolean. So I was also able to make you understand that you can also make a variable to be a constant, or you can define a constant. We always have constant in engineering, in scientific uh, uh, world. We have a lot of constants. So you can. So one thing I want you to know that can, any problem you can define is input, you can define is output, and the process, you can write the code for it. Okay. So this is um, variable declaration assignment. That's one thing I wanted to show you before variable. For you to assign a value to a variable, you use equal to, which the equal is an assignment operator. So every time we want to assign, okay, I want to assign this, the result of pi times 5, I want to assign it to radius, you use equal to. It means do this computation on my right hand and put it in this variable on my left hand, which I've defined. Okay, so equal to is an assignment operator. This is a multiplication operator and all that. Okay, so that's variable. I want to make you understand that. Then we could actually go to what we call decision. I've, I've also specified this for you to create every variable. Every variable in C or C++, any variable in C or C++ must be declared before it's used. Before you use any variable, it would just imagine I come here and say, oh, give me H. Any attempt to run it, it will give you an error. It will say, why are you calling this variable? I don't understand. So look at it. Age, undeclared. You've not declared it. This is the first time I will see you use it in this function. You've not declared it. It's just like someone, if I come to your house and I say, oh, Bingpe asked me to collect 5 million from you, and say I don't know Bingpe. But if there's Bingpe you are aware, so you declaring is you are making the compiler aware that this variable exists and I would use it. So any attempt to just declare that age before, maybe I could also assign it the value, then there will be no problem. Okay, there's no problem for us. Okay, there's no problem. So you can see also when I was trying to print it, it did not print the right value because age is an integer and here I'm using a floating point. So look at it, I ran it, I'm having 0.00 whatsoever because I'm using a formal specifier that it should treat it as a floating point. No. So for any attempt to say, you can see I'm having the right value. Okay, so by the side, I've also talked about comments, single line comments, multiple line comments. Okay, so you can have a single line comment if it's have to do and say, oh, printing, what am I doing now? I'm printing the value of age, value of age. That's comment. It will ignore it. The compiler will ignore whatever comment you've made. But this comment will guide whoever is reading it that, yeah, this is what this person is doing at this point in time. Is that clear? Hope you understood what I've just explained, guys.
Yes, sir.
Yeah,
Yes, sir.
yeah, good, good, good. You can go to my YouTube channel. Um, Sometimes I upload some of these things. This is my YouTube channel. You can type it and follow along. You can see some C++, um, programming language there. You can just watch it. C++, they have the same structure. Okay, so that's just it. So let's move on. Let's move on. So I've talked about variable declaration. The next thing I need to make you understand is decision. Decision. Okay. So in programming, you will always make decision. Every day of our lives, we make decision, and those decisions have to be reflected in our program. Okay. Every day you wake up, you make decision. Oh, when I wake up, what should I do? Should I pray to God? Should I pray my phone? You make decision. Which app should I use? Which food should I use? Which path should I take to my campus? So we make decision. So in programming also, we have to make decision. If I slot the ATM card, if the pin is correct, let the person be able to withdraw. If the pin is not correct, let the person not be able to withdraw. Okay? If the person time out after certain minutes or certain attempts, exit the card. Oh, if the person has withdrawn twice, uh, tell the person you can no more withdraw. We make decisions in programming, and those decisions um, have to be reflected in programming. So there's nothing like programming without making decisions. You always have to make decisions. Okay, so and your decision will, that you're going to make will be based on maybe your current value, the current value, or your current input. Your decision has to be based on your current input, the current value of your results, or your or any calculated result. Okay, so the decision, if you look at it, one of the most important facet of programming is ability of a program to take different course of action. Different course of action. It can move forward, it can move backward, depending if you're right or wrong. You know, if you go to your browser facebook.com and you input the wrong password, it should not allow you to go. If you put the right username and password, it should take you to the next page. So that's decision making. Okay. So, and it will depend on the input, whatever you input to the program. If you input the right ATM pin, fine. It allows you to move forward. Wrong ATM pin, it bounces you out based on your input to the program. Okay, or the calculated value. If I calculate my CGPA now, depending on the CGPA value, it tells me I'm in first class, I'm in second class. You understand? So based on your input, your calculated value, okay, or your stored result, it will make decision. So which course of action to take is decided by a conditional statement. You have to make it the conditional statement. Okay. So before we even move to now C++, so that I'm just trying to adapt this um this slide for you because I could teach you without using the slide, but it's good for you to see all these things. So for you to make decision, we always have some operators in C or C++. And um, those operators helps us to make decision. And I will show you how it's been done. Look at it. In mathematics, if you want to compare two variables, is x equals to 3? Is x equals to y? You understand? You use equal to, right? Are, are you with me? In
Yes,
mathematics also, you want to compare, is x less than or equal to? So you always have less or equal to, greater than equal to, less than, greater than. The last one is what? Not equal to. That's what you do in mathematics. Ah, is this size equals to this? That's comparison. If you want to make those comparison, you do in mathematics, this is what you do, equal to. But in C++ or C, okay, if you want to make comparison, relational, relational in the sense that you are comparing two things in relation to each other. Is this girl fatter than this? Is this girl bigger than this? Is this girl smarter than this? You are relating two, two variables. Okay. So in C++, if you want to write, or C, apologies, in C or C++, if you want to compare two things and you want to see if they are equal, you use double equal to. You use double equal to. Why? The single equal to has been used for what? Assignment operation. So we use double equal to. So if I'm here now, age is 50. I can say if age is equal to 50, I'm making a decision. If age is equal to 50, print yes, yes, it's equal. Okay. If age, you can see I'm comparing age and 50 together. Yes, it is equal. Okay. Age is 50. So is 50 equal to 50? Yes. Okay. So I don't want to go there for now. I just want you to understand that for us to make comparison, we use this double equal to. Why? Single equal to is for assignment. Is that simple enough, guys? I want to be sure that everybody, we're all on the same page. Is that, do you understand what I've just said?
Yes, sir.
Yes, sir. Yes, sir.
Okay, any other person I want to get feedback from as much people?
yes, sir.
Yes, sir.
Okay, that's good. That's good. So I will still tell you how to build all these things. Just follow me. Okay. So in mathematics, if you know in mathematics we say x is less or equal to 2. You understand? is less or equal to 2. It means from 2, if you look at the time, so from 2, x is from 2 downwards. Okay? So less or equal to. So in C, we also use the way it's being pronounced. Less or equal to. So less or equal to. You can see, you write it together. Greater or equal to. So you say greater or equal to. Is x greater or equals to 5? Okay. Is it less than? Is less than? Is it greater than? Now, this is not equal to. In not, we write this operator, this not operator. You can see, look at it, not logical, not equal to, not equal to. Do you understand? So that's how to write it in C. If we can also make logical comparison between two numbers, and you can do A and B. A and B. So one thing about and also is for it to be executed, for the next statement to be executed, this has to be true. Remember, I don't know if you've done anything on Boolean algebra. In Boolean algebra, you have. That's awesome. That's awesome. That's awesome. Let's say you have to do input or two variables. You always have four scenarios: 0, 0, 0, 1, 1, 0, 1, 1. Now, if you say C, the output should be A and B. A and B. Okay, let's say A and B. It means your output will only be true if the two cases are true. So 0 means false, 1 means true. This is false, this is false, it will give you false. This is false, this is false, this is true, it will give you false. This is true, this is false, it will give you false. It will only give you a true when both of them are, it means it is compulsory. Those two are compulsory. Do you understand? These two logical comparisons are compulsory before you can have the next statement being executed. But in or, what do you have if it is or? Let's say A or B. A or B. Means or means either of them can be true. If either of them are true, I'm okay. So if I say Samuel, a class rep, I will go to the cinema if Samuel and let's say Bingpe follows me. If Samuel and Bingpe follows me, I'll go to the cinema. If Samuel alone shows up, I will not go to the cinema. Both conditions must be true. Both conditions, both Samuel and Bingpe must be true before I can go to the cinema. But in all case, either of them. So if Samuel or Bingpe is around, we can go, I can go. Or it means if you have 0, 0, in all, it will give you 0. Then you have 1. 1. As long as one of them is okay, then so this is all case. And not, the not case, or maybe they might have taught you about the logic gate. You have AND gate, OR gate, NOT gate. NOT will always invert whatever you have. So if you have 0, let's say this is A, and you have NOT of A, NOT of A. And A can be that's true or false, 0 or 1. If you say not means inversion, invert it. 0 becomes 1, invert 1 becomes 0. Or sometimes they call it complement. So A complement. So they put it bar like this. So if it's 0, invert it it becomes 1. If it is 1, invert it, turn it the other and become 0. You understand? So we always, in this logical comparison, we always compare two logical statements, and based on that, we'll make our final decision. That's it. So let's try it out. Let's try it out. Before I try it out, in making a decision, there's a statement called the if statement. For us to, that's the beautiful thing about C and C++ and all other high-level language. The code or the keywords resemble human-like statement. I want to go out. Oh, if it is raining today, I bring umbrella. Even if you are not a programmer and you look at this, sometimes you can make logical sense out of what someone has written. If A is equals to 0, oh, otherwise, so there's if statement. If statement. So how do we check? If, then you open your parenthesis. You put your condition in that parenthesis. The condition to be checked, you put it in the parenthesis. If age is equals to 50. Now, let's say age is equal to 5. So remember, age is 5. So it means wherever you see age, it's 5. Is 5 equal to 50? No. This condition, if this statement has to be true, if this statement has to be executed, this condition must be true. Must be true. This condition must be true. Okay? So is 5 equals to 50? No. So it will not print this statement. Look at it. You will not see anything. Can you see? You can't see anything. But if it is 50, is 50 equal to 50? Is 50 equals to 50? Yes, it's equal to 50. You will see it. Yes, it's equal. You understand? So let's say that's for equality. You want to check. What about is greater? Now, 50, is 50 greater than 50? Will it print this statement? Guys, will it print the statement?
No, sir.
No, sir.
So,
Why?
50 is
because
not great.
it's equal to 50 and not greater.
Good. I love that. God bless you. 50 is equal to 50, not greater. It's not greater. Smart way of thinking. So it's not greater, is equal. So you will see it does not execute. It does not execute. But let's say it's 55 or 59. Is 59 greater than 50? Yes. So you can see this statement is true. Okay? Good. Greater. Okay? So that's if statement. Okay? So if will always check if it is true. I want to do something. If true, if true, will this work? Let's see. I want to ask you guys, will this work?
Yes, sir.
Why? Why will it work?
Because the 3 years like a bonus. But
Yeah,
I don't know.
yeah. So remember, what would be in this parenthesis if it evaluate to be true, it will work. True is true, not true. True is true. Do you understand? It's true. You can see it does not work. True is true. Okay. Let me also give you um the mistakes some students make. Look at this. Some student does this. let's say, let me do this. They want to compare. They want to compare age. Is 59 equals to 50? They want to compare. And instead of them using the double equal to, they mistake by doing a single equal to. Now, the question is, will this work? Oh, guys, will it work? I just want to hear from you.
No,
Guys, will it work?
no, sir.
How many of you are saying no? I want to know.
No, I want to know.
How
That's
many?
me, I guess.
How many? You can put it in the comments box. Yeah, put it in the comments. I just want to see. I want to teach you how you can be able to track. Please always mute your mic so that. How many? Let's see. Let it come. Let it come. No, I think an error will come up. Okay, let's see. I think an error. Good. If you're online, no, no. Any other? I want more people to. No. If you're online, your comment. No. Good. No. Okay. Let's see. It will shock you. It will shock you. It is yes. It will shock you. Now, the question is why? Why is it executing? Why is it executing? I know some of you might. It will execute. Equal, not. No, that's not the major reason. That's not the major reason. Adebo, okay, that's not the major reason.
I mean,
Do you want to comment?
So
okay.
something.
Okay,
It's
Samuel. Yeah, go on.
the reason why it works is because we are assigning the value 50 to the age integer, and it's
Yeah.
like true that we've assigned that value. It's not checking for anything like the statement.
Okay, that's a very nice try. That's a very nice try. Now, when you're comparing, when you're checking, okay, remember it evaluates to be true. Anytime you're checking and it is not zero, it is not zero. Remember, true means at least one, Abi. True means one, false means zero. As long as it's not zero or less than zero, or it's not zero thereabout, we can try it. It means it's true. So whenever you are assigning a value, age is not zero. Okay, it's true. Okay, so true is true actually. So anything not zero is true. As any assignment, so I don't know how I will interpret it. So you always have to avoid using assignment. You use double equal to. Okay, let's do a logical statement. Let's say I have int pin and my pin is equal to 1111. Okay, my pin, or I can say pin. I can make a is age equals to 59 and pin equal to, you can see, equals to 1111. If it is equal, it will tell me. Do you understand? Is my age equals to 59? You can see, and so this and, which is a logical comparison, you can see it takes two conditions. Those two conditions must be satisfied. if age is equals to this and this is equals to this, and you can even have third, fourth, fifth. And let's say cha name, let me just say my name, cha a, and name equals a. Print, yes, it is equal. If all these things are satisfied, or I can come here to make it easy, I can say username. Let me just delete this. If the username and password, I can come here and just say password. So if username and your password, you can see I wrote pin. It will give me an error. It should be password. I did not declare any variable called pin. If pin and password is the same as the one I have before, yes, they are equal. Then I can move on. You can see, yes, it is equal. But let's say my username is not, this username is A and I am inputting P. It will not execute. Can you see? So this and helps you test two conditions or more, two or more conditions. Okay, so that's it. Now, if this is true, print this. Otherwise, sometimes you might otherwise print it's not true. It's not true. So right now, what will lead print? It will check if it is true. Otherwise, it will what? Print it's not true or is not equal. So with this statement, with that condition, or I can say invalid username and password, I can come here and say invalid username and password. Okay, can run. You can see what it's giving me: invalid username and password. If I have the right username and password, what will it tell me? Yes, it is correct. You can see there are so many things you can do with decision making. Okay, sometimes you can do some advanced comparison. Let me give you an example. Let's say you want, based on the inputs. I know I've not taught you this, but let me just for teaching sake, let me show you. Let me try this. Print username. Let me make it blank. Pin my password. Let me make it blank. My age. Let me just delete this. Okay. Okay. So let me come here. Now I don't have a password. Okay, let me just say my password. My password is 1111, and let me say my username is A for now. I've not taught you how to do strings. That's why I'm limiting it to just one character. By the time I teach you how to do strings, you will have a full name like this. I've not taught you, so that's why I'm limiting it. So let's say my username is this, and I want to ask my user, please input your username and password. Okay, let's say the person has a prompt telling it, please input your username and password. Okay, so there's for me to accept anything the person types, there's a function called scanf. Scanf, I I I allow it. I'll give it the format specifier. Your username. Okay, so my username, because I put the prompt username and password. So username, the format specifier for username is character. So I will say %C, and my password, my the for password is integer, right? So I will say %D. Or let me do this way so that please input. I can just say please input your username. I don't want to go advanced. So I just say my username is a character. So I can do this address of username. Okay, so I can come again and ask the person, please input your password, and password is an integer, so I come here and say password. My password is an integer, so it's a B. Okay, so I can come here and say if password which I input is equals to 111 and username is equals to a parenthesis. So let's see if it works. So look at it. It's prompting me now. Input your username. Input your username. So let's say my username is B. Okay. I failed to input my username. I press enter. It's telling me input your password. So let's say my password now is 1112. You can see they are wrong. So when I click enter, it tells me what? Invalid username and password. Both of they are not correct. Okay, I can exit. So you can see that I make decision. I make decision based on if they are correct or wrong. Okay, but if they are correct, let me run it. Input your username, my username as A, and my password as 1111, 4 ones. You say yes, it is correct. So depending on the input, it will check if they are true. If it is true, it gives me this. If it is false, it will give me this. Okay. So sometimes, sometimes we want to check so many things, more than one statement, more than two statements. We want to check more than two statements. So we always use if, else, if, something like if, else, if, um, else, if, okay, else, if this condition, another condition. But however, the last will be an else statement. The last will be an else statement. Okay, so that's how we do it. So it's first of all check if this is not true, it jump here. If it is not true, it jumps here. If it is not true, it jumps. So can I give you a scenario? Yeah, I can give you a scenario. Okay, so let me quickly do this. Blah, 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 blah. Input your score. Let's say score, or let me just create a pass. Just say score. Maybe you add a score. Input your score. Score. So if score this score is less than or equals to 100, less or equals to 100, print you you got A. Okay, you got A. Otherwise, if score is is greater or equals to 60, you can see. So what is B? B starts from where? Greater or equals to 60, and the score is less than 70. Okay, the score is less than 70. That's that is B. Then you can write you got B. Okay, so I can come here, say you got B. Can also come to test this condition. If score is greater than 50, greater or equals to 50, but is less than 60, that will give me you got C. Okay, so let's stop it there. Otherwise, what should it print? It should print you failed. You failed. You got F. Let's just say you got F. Okay, so let's run and see. Oh, okay. I made a mistake. I should have carried you along. So let's say 90. What will 90 give us? A. Okay. I should have told you input your score. Print F. Okay. Input your score. Okay. Input your score. It's done. Sorry. So this first line, I created a variable to store whatever I input. Okay. You create a variable to store. That's essence of variable, to help you store. Okay. Then I use scanf. Whatever I typed in through my keyboard should be stored in the address of score. Should be stored in score. Okay. Using the scanf operator. So then I test if score, whatever I input, is that number less or equals to 100? If it is that, you got A. Otherwise, it checks here also. Is that number greater than 60? Greater or equal to 60? So if it is 60, it will still tell you you got B. As long as it is within this boundary or this, you know. So if it is not there, you got F. Okay. So I can come here also if score is less or equal, or I can do this, or okay, score is greater than 100. In case maybe someone just put anything greater than 100, I'll just give you A. I don't know how possible that can be, but you have your exam score. You can, so how do you write or? You can see or. So score less than 100, maybe from 70, you understand? You can add code it from 70 to 100, to anything above. Okay, so I can even add code it here. Say if score is greater or equals to 70, or greater than anything, I can bound it, or I can say and score is less or equals to 100. Between this range, can bound it. So let's say I put 40, anything 49, you failed. Okay. 45, you failed. Good. Let's say 59, you got C. Good. It's working. on 65 or 67. 67 will give us a B, right? You got B. 79, you got A. You can see it works. So these are ways you can just write codes and you know. So that's decision making for you. So my time is up. Don't let me bore you. We've been able to talk about variables today, and we've started with decision making, okay, using if statement. We've talked about the operators, the relational operators, okay, and the logical operators. We've done something significant today. So, do you have any question, or else we call it a day? It's past 6. Any question? I hope you
So
understood. Yeah,
I want to ask, if you're writing CP115 test
yeah,
exam and we are required to um, do a program or make a program, are we
yeah.
going to use code blocks or we're allowed to use any idea of our choice?
So for me, what I would want you to do is all of you get code block so that you'll be on the same platform. So that I myself I'll be on the same platform. So you get code blocks. Everybody go. Although in practical ways there are more than you can use anything. Okay, you can use, but everybody you get code blocks and you are familiar with the interface. I think that's the way to go.
All right, sir. So are we also going to get in the
Hello,
slide?
sir.
You don't need a slide.
All right.
Yes.
Hello, sir. So how are we going to get code blocks?
Go online, it's there. Just go online, how to install code blocks. It will guide you. Follow the process. Are we good? There are videos online. Code blocks on Windows 10 or Windows 11 will tell you. You can see videos. So follow them. You know, that's how, those are part of learning. Any other thing?
So
Yeah.
when the class started, I noticed that the class was being recorded. Is it possible
Okay.
for us to get that recording? Like those are because of those that were not able to attend the class
Well, it's
because of
fine. Yeah.
that.
If you get the recording, I just upload it to my YouTube so that you can watch. Okay.
All right, sir.
No
Thank you, sir.
problem. I'll try to save it. Okay. All right. Take care, guys. We see some other
Fine.
time.
Thank you, sir.
I hope you have learned, and I want you to go and practice. From today, go and get your code blocks. All right?
Yes, sir.
Okay, sir.
Yeah. All the best.
Thank you, sir.
You can
Thank you,
see
sir.
again. You can see again. I never have any code I'm looking at, any sheet I'm looking at. Everything comes and it flows, and that's how it works when you know what you're doing. Okay. So take care, guys. All the very best.
Thank you,
Yes,
sir.
sir.
Yes,
Yeah.
sir.
Bye.
Yes.
Bye.